524 days into what was planned as a 35-day mission, Ingenuity sits on Mars, 297 million kilometers from Earth. This tiny 680-gram helicopter, built from off-the-shelf parts, Android smartphone components, cordless drill batteries, has far exceeded every expectation. But now Martian winter approaches. Night temperatures plummet to -85 degrees Celsius. As Mars drifts farther from the sun, violent dust storms kick up, blotting out the sky. On Sol 427, the team at JPL tries to make contact. Nothing. They try again. Silence. All signs point to one conclusion. Ingenuity is dead. 6 years before this moment, Ingenuity was just a concept that NASA didn't believe in. Kenneth Farley, project scientist for the Mars 2020 Perseverance mission, openly opposed it. Spending 30 days working on a technology demonstration does not further the goals directly from the science point of view. Most Mars missions receive billions in funding. Ingenuity got $80 million, less than the budget for the movie The Martian. But this scrappy team was determined to prove a revolutionary concept: powered flight on another planet. February 18, 2021, Sol 0. The Perseverance rover survives entry and touches down on the Martian surface with Ingenuity attached underneath. The team severs the umbilical cord, and Ginny, as she's affectionately called, prepares for her mission: prove that flight on Mars is possible. The challenge is immense. Mars's atmosphere is just 1% as dense as Earth's, making flight extraordinarily difficult. Ingenuity must be ultra-light, and her rotor blades must spin at over 2,400 RPM to generate sufficient lift, a design no one was certain would work. For 2 months, they meticulously check her systems, testing navigation, control computers, and engines. Finally, on Sol 58, the moment arrives. The blades spin up, and she lifts off. Just 120 years after the Wright brothers, humanity achieves powered flight on another planet. Within days, they fly again and again. In 1 month, 5 successful flights, mission accomplished. We were a tech demo, right? A specified, narrow 30-sol mission. Get in, get out, we're done. Go to a bar and party, that should be the end of it. But success breeds new expectations. NASA orders them to continue. Ingenuity's new mission: assist Perseverance in searching for evidence of ancient life on Mars by scouting ahead and gathering data in areas too risky for the rover. The team is thrilled but unprepared. There was no guarantee after Flight 5 we wouldn't be dead by Flight 7 or Flight 10. We were thrown into the deep end with no processes or plans developed for such a thing. Until now, every flight had been meticulously planned, tested hundreds of times in wind tunnels and thousands of times in simulations. Now they're flying into the unknown. Flying Ingenuity isn't easy. Mars is at least 56 million kilometers away, meaning a minimum 6-minute round-trip communication delay, far longer than Ingenuity's 2-minute maximum flight time. She must fly autonomously. Without GPS, which requires 24 satellites, Mars has only 7. Ingenuity uses a simpler method: visual navigation. A downward-facing camera captures 30 black and white images per second. Her computer analyzes these images, identifying surface features like an optical mouse tracking movement across a mousepad. By watching rocks and landmarks move between frames, she calculates her position. On Flight 6, her first time leaving the testing area, disaster nearly strikes. 54 seconds into flight, Ingenuity wobbles wildly, tilting 20 degrees at a time. Emergency alarms blare. The culprit? The color camera, added late in development with minimal testing, sends an image at the exact moment a black and white navigation image arrives. The system drops the black and white image, putting every subsequent frame one step behind. Ingenuity thinks she's lagging when she's actually on target, so she overshoots, overcorrects, and wobbles worse in a positive feedback loop. Fortunately, she detects the problem and emergency lands before the death spiral becomes fatal. JPL identifies the bug and patches it remotely. After 12 successful support flights, Flight 19 approaches. Then JPL receives a call. There's a dust storm brewing near Jezero crater. They cancel the flight and hunker down. For 6 days, winds gust up to 20 meters per second. That first dust storm in the middle of fall clobbered us. But Ingenuity survives. Two new problems emerge. Dust covers her solar panels, reducing power by 18%, and dust jams her mechanical servos. JPL works around these issues by adjusting flight durations and repeatedly wiggling the servos until they clear. Wounded but operational, she continues flying as conditions worsen. Mars has extreme temperature swings. At the equator during the warmest part of the day, your feet might feel 23 degrees, while your head experiences 0 degrees. Between day and night, temperatures range from 27 degrees down to minus 133 degrees. As Mars moves farther from the sun into winter, nights grow even colder. This threatens Ingenuity's hand-soldered electrical connections and battery electrolyte solution. To survive, resistance heaters keep temperature-sensitive components warm inside an insulated box, consuming 60 to 75% of battery power each night. The colder it gets, the harder the heaters work. If they can't keep up, batteries become less efficient, supplying even less power to heaters. A vicious death spiral. May 3rd. The team checks the previous downlink. Nothing. They ping Ingenuity. Still nothing. Is this the end of the mission? We thought this was it. They refuse to give up without exhausting every possibility. They narrow the problem down. If Ginny fully depleted her batteries, she would have powered off completely. When the sun rises, if her components still function, she might recharge and wake up, but her internal clock would have reset. They calculate that based on sunrise, she should wake at 11:45 a.m. Martian time, not when they'd been calling. They adjust their search window and send out pings until finally, she's alive. Everything works despite being completely frozen, except one component, the inclinometer, which tells Ingenuity her physical orientation before flight. Without it, she can't fly safely. The team has a breakthrough. Ingenuity is built from smartphone parts, a Samsung Galaxy S5 processor, and Google Pixel 3 sensors. Inside every smartphone are accelerometers and gyroscopes forming an inertial measurement unit, IMU. These micro-electromechanical systems measure acceleration and rotation by detecting changes in capacitance as tiny suspended masses move. They reprogram the computer to use the IMU to replace the inclinometer. We got lucky that the one instrument we could afford to lose was the one that died. These consumer-grade components face another threat: cosmic rays. Mars's thin atmosphere allows cosmic rays to reach the surface, potentially flipping bits in computer memory and causing crashes. Surprisingly, the off-the-shelf components hold up far better than expected. Rather than building a radiation-tolerant processor from scratch, you get better bang for your buck by buying batches of processors, running radiation tests, and flying the ones that hold up best. Ingenuity survives winter and, with increased spring sunlight, returns to full capacity. Over the next 41 flights, she images inaccessible craters, captures stunning aerial views of the Martian horizon, conducts aerodynamic tests, and pushes limits. To fly faster, they fly higher, expanding the camera's field of view so features move more slowly through frame. From an initial 10-meter altitude, they reach 24 meters. Speed increases from 2 to 10 meters per second. Speed records, distance records, altitude records, everything we could think of to push that flight envelope and make the most of this once-in-a-lifetime opportunity. Ingenuity and Perseverance reach Nuretva Vallis, a river delta in Jezero Crater. On Flight 71, a new problem emerges. Flying over featureless sand dunes, her camera can't identify enough landmarks. She loses position tracking and emergency lands hard. Surprisingly, she survives intact. They attempt Flight 72, a simple vertical test. Up, take pictures, back down. We hit the same problems as Flight 71, only this time it's fatal. Perseverance captures images of the crash site. Ingenuity's rotor blades are scattered, broken. When we saw that first image after Flight 72, that was heart-wrenching. This marks the first aircraft accident investigation on another planet. The team notices something strange. No blade strike marks on the ground. If the spinning blades hit the surface, they'd create a visible spray pattern. So what happened? The rotor blades, carbon fiber composite with foam cores, failed due to gyroscopic precession. When Ingenuity hit the dune at an angle during the hard landing, forces transmitted through her body created precession torques that bent the rotors. They snapped precisely where reinforcement tapers off, exactly as physics predicts. This thing came down hard. It didn't destroy the landing gear, avionics, or servos. The rotors, that's the weak link. Armed with lessons from Ingenuity, NASA is developing Chopper, the next-generation Mars helicopter. Key improvements include reinforced blades to withstand hard landing torques, 6 rotors instead of 2, enabling heavier payloads, direct-to-orbit radio communication, no dependence on rovers, 5 kilograms of scientific payload capacity, 3-kilometer range per Sol, covering in minutes what takes rovers weeks. Chopper will launch using a mid-air delivery platform, descending through the atmosphere with a jetpack, slowing to a controllable regime, then taking off under its own power. No complex sky crane required. There will be fleets flying throughout Mars. There will be airports on Mars one day. Still attached to Ingenuity's underside is a 1 square centimeter scrap of muslin fabric, taken from the lower left wing of the Wright Flyer, connecting the first flight on Earth to the first flight on another planet. From Ingenuity's resting place on Mars, her spirit lives on, and she isn't quite dead yet. She's acting as a weather station now, capturing photos and temperature measurements every day, something no one would have predicted before Flight 72. So she's a tank. NASA once doubted this mission, but Ginny showed what's possible. As one engineer reflected, in 1890, if you'd said, "I'm gonna fly," people would think you're a kook in your garage who's gonna kill himself. After the Wright brothers, it became something we're gonna do. That's the change in mentality that occurred because of Ingenuity. Mission stats: 524 days on Mars, 72 flights, countless hearts won, and still transmitting.